Hello everyone, welcome to Lean and Kanban webinar for me Midkoda. My name is Hannu Törmänen. I'm a coach at Ericsson Finland. So I mainly use Lean and Agile tools in my work when I coach teams and development organizations. Today we are kind of taking an overview of Lean development, Lean practices. And hopefully you get some insights what Lean is all about, and get some ideas in your daily work as well for those principles and practices. And also today we are going to touch a little bit of Kanban, so how that makes Lean work, Lean flows visible, so that everyone can easily see where we are heading in our work. So to next, just a moment, I had some difficulties here, but yeah, the content for this talk today is really to speak about what Lean is, and I will spend quite much time on discussing this resource versus flow optimization. So how does Lean tackle that kind of a problem where we have a kind of a hard resource usage and how to get rid of that and make this flow happening, so we get more done in a shorter period of time. And yeah, and also we will talk about Lean practices from several angles. Also some principles are being touched. So what the philosophy behind this Lean thinking. Also some discussion about Lean, what are Lean thinking principles versus Agile thinking principles, or are there any contradictions in that kind of two domains, in a sense that do we find actually similarities there? And yeah, and then speaking about Kanban, I will walk through the basics of Kanban tables. What does it mean really, and how they are handled to visualize work. And then we have an example by using a Kanban table, how this Lean practices and Kanban can be combined in product development. Okay, so if we go to this question, what is actually Lean? So as you may even know that Lean practices started from manufacturing, and especially car manufacturing. So what you see in this slide, it's kind of tries to define the Lean principles and practices, and what is the idea, the core ideas behind it, the whole thinking model. So the first occasion when the word Lean was mentioned is from a guy called John Krafcik, who is currently a CEO of Waymo, which is actually a Google's self-driving car unit. And back in 1988, he was a researcher at MIT University in the United States, and actually he was studying what kind of production models for cars we can have in that era. So in 1988, he studied a number of plants where cars were manufactured, and in different continents in North America, Europe, and Japan. And he actually found out that not every plant is the same. There's quite many differences how they operate, and he especially found out that this kind of a operation model, which is kind of a strong culture being built into the plant, and management is really up to speed where we are what we are doing in the plant, it really makes a difference as they were able to produce good high quality cars in that environment. Also the robotics, how much they are using robots in the manufacturing process didn't really play a big role. And he called this production model lean, and that's when the idea of calling this kind of production model as lean production was kind of first mentioned. But you can see here also some other definitions, like what is the Lean Enterprise Institute, which is a kind of a body who is kind of promoting these lean practices. And they say that the core idea is to maximize customer value while minimizing waste. So we put customer in the center, try to produce as much as possible customer value, and try to do it in an efficient way. So create more value for customer and use less resources. And also this definition from Womack and Jones is one definition there that says that we are doing more and more with less and less, spending less human effort, less equipment, less time, less space, less energy, and eventually we are providing customers exactly what they want. So there's two kind of things here: maximize customer value and trying to do it as efficiently as possible by spending less resources. So that's the key idea of this lean thinking. So if we go from there, so these kind of basic ideas of lean thinking. So what are the kind of cornerstones? So James Womack and Daniel Jones were the ones who wrote the book in 1996 about lean thinking, and they came up with actually five different principles that you could characterize lean thinking. So what is it? So it's providing customer value, put customer in the center, and hear the customer, see and hear what he or she is hoping for, and try to organize yourself for around that value. And in order to find how the value is really provided, so the value stream is kind of essential to understand. So identifying the value stream for the product you are making or manufacturing, and challenge the value stream. Are there any unnecessary steps, or is the steps that we are doing while making this product, is it really adding value to customers? And try to identify those steps that are not doing that. And next thing, when you have identified your value stream and you have kind of understood that, okay, what really in those different steps adds value and what doesn't, then you try to optimize the value flow and try to make it continuously, so that all the steps that are remaining and bringing value in the process then can flow seamlessly from one step to another. And then in order to make the flow happening, you need to introduce something called pull. And pull is something that you just kind of don't waste time waiting for something to happen, but if you try to minimize the waiting times and introduce the pull between all the steps, and so that the continuous flow is possible to make. And finally, you would you would then try to just tweak the system and make improvements and try to make the system perfect, so that you have taken perhaps still more steps away from the process and stay saving time in producing the actual end product and save the customer needs as efficiently as possible. So these 5 steps kind of are a key to understand if you're speaking about lean thinking. Okay, so there are many areas where lean can applied, and there are a number of books written about lean in different domains about different enterprises, different companies, and so forth. So if you search lean related books, for instance, in Amazon, you will find more than 10,000 different results from there. So there are quite many areas where lean is applied, and several books are written about those areas as well. But if you would like to have something that really is kind of a generic and can introduce kind of a basic thinking and in a very understandable way, and it's not too academic to understand, I can recommend This is Lean book by Niklas Modig and Per Åström. They are Swedish researchers, and they have written a nice compact book about lean, and it's also available in many languages, including Finnish. And so it's called Data on Lean, if I can remember correctly. And you can find it even in your local library if you are interested. There may be queues, but anyway, yeah, it's available at least in the Helsinki metropolitan area. Okay, so the scope of where lean can be applied is quite huge. So and you can deep dive into these areas for something that is, if you are interested for lean UX, for instance. There's a book about that as well. Okay. Moving forward, so I mentioned earlier that I will talk a bit about this resource and flow optimization. I will use an example from This is Lean book, which is kind of makes you understand what we are talking about here. So if we go to this one example of resource, what is resource optimization? So you could meet Allison, who has a cancer, has a breast cancer, and she wants to be examined by a doctor and get to really the clarity if I have a cancer or not. And what usually happens in today's healthcare is that if you go to the public sector, for instance, then you have to contact your local doctor, and it takes time that you will get an appointment for a local doctor, and then you have an appointment and go there, and doctor is very busy and has a full schedule all day long, and maybe he or she is able to give you 15 to 20 minutes to examine you and decide if there's something that we really should take a look at later on by some experts. And then the local doctor will send you to the next phase when you get some kind of pre-examined examinations done. Like for instance, in this case, you go to mammography and ultrasound, and there you have also some time, and then after that you spend some time there, they take the tests and so forth, and then you will get to see the specialist in the breast clinic, and then they will decide that, okay, yeah, we need some more tests here. We need to have a more examination, take a sample of your breast and then see if it's really cancer or not, and then you go to the next phase and see the results and hear the results. Okay, is this really cancer or not? Yeah, it works, but there's a slight problem there, that it may take you something like 42 days to get from your first contact to a local doctor until you get the final diagnosis. And if you ask Alison what's your opinion on that, so well, maybe she doesn't think about that. Okay, yeah, I got examined, and after 1 month and a half, I got some results. Yeah, but actually, if you put Alison in the center of this whole process, then you can see that she will spend most of the time in these 42 days waiting for something to happen, and the people who are working, the local doctor, the medical staff doing the examination and doing the checkups and so forth, they are quite busy. So you have queues for them, and for like Alison, you have to wait several days or maybe weeks until you get examined in the next phase. And if you try to calculate what is the real efficiency of this process from Alison's point of view, you get something like 0.2%. You get to spend something like 2 hours in these different islands. We can call them islands. So he gets to know. He has a VIP treatment in each of those islands when she arrives there, but if overall she spends something like 2%, and the overall time to get the first contact into diagnosis takes more than 1,000 hours. So you come up with this is 0.2 efficiency of low. Okay, and when you think about it that way, it isn't truly very efficient. But if we try to put the customer in the center, and let's meet Sarah here. So she's having the same kind of feeling in the breast and trying to figure out that, okay, maybe I should get it examined, and she makes the contact to this one-stop breast clinic, and where they can handle less patients at the time, but all the stuff and all the equipment needed for the examinations and tests are available under this same building. And once Sarah gets an appointment, they get everything done in one go. And yeah, if we assume that she spends 2 hours in total in the breast clinic, where everything is being done for her as a VIP, then you calculate, okay, what is the real efficiency of this kind of operation model? Yeah, maybe she spends 2 hours and has to wait something like half an hour for the next phase at the clinic, but you get something like 60% flow efficiency in this case. So that's kind of a dramatic change if you compare it with the 0.2% what we had with Alison in the earlier slide. So yeah. So what is this whole kind of thing that really is a difference here when you are speaking about resource versus flow optimization. So if you speak about focus, for instance, then and what is the parameter of focus? Is there in the resource efficient model is the doctors and the nurses and the equipment that they have to be their time has to be optimized, and the function that they are running, like this mammography or ultrasound, it's getting a maximal throughput per day in that function. So you get tens of mammography pictures or ultrasound examinations done, which seems to be very efficient. So, but if you're talking about from customer's point of view, you don't have that kind of experience that, okay, there are several steps you have to go through, and then you don't really experience the flow. You have to wait a long time to get to the next phase and so forth. So if you're talking about flow optimization, then the customer is the flow unit in that sense. So the eye is on the customer. And the goal for resource efficiency is to utilize the capacity to the maximum and get them really maximize the time that we get from doctors and the nurses and so forth. But in flow optimization, we try to fulfill the customer needs better. From the organization point of view, you are working in islands, on parts, and quite a sub-optimized way. But in a flow system, you try to focus on the system and have the kind of ocean thinking that, okay, we are on the ocean and we have to navigate there to get from A to B, so to say. And in this competence-wise, you have depth of specialists there. You have the nurses who really know how to take mammographic pictures and images, and you have the depth of knowledge in those siloed kind of units. In contrast, in the flow efficiency, you have the multi-competent team available. You have all the people in the same kind of a unit, and you can easily ask advice from other experts. As an advantage for resource efficiency is the economics of scale, so meaning that you will get the most out of your resources, and your cost per unit perhaps is lower than in this flow optimized model. You have flexibility. You have the deep experts there who can do this, specialize in this one task, and it's easy to organize the work as the work is not that complicated. And yeah, in flow optimized behavior, you focus on the customer. Maybe you see the big picture all at once, that okay, how many customers are we dealing with today in this one-stop shop, one-stop breast clinic, for instance, and what is the status of each of these patients today, so we know what we are doing next with all of them. And the disadvantages, yeah, you get easily sub-optimized into this certain function, and you have limited system understanding. But in flow efficiency, also you may sometimes lack the knowledge in some deep expertise areas, and the system isn't that flexible. So if you have someone who is on sick leave, for instance, it's not easy to fulfill his or her expertise. So that's kind of an overview of how this resource and flow can be kind of thought out. And yeah, so flow optimization, you try to receive the value from the flow, and the customers are treated as VIP customers, and their time is prioritized. And for resource optimization, the persons who are working in these silos and all the equipment are the VIPs, not the customers. And it's quite hard to kind of have the kind of optimal balance between those kind of ways that, okay, we don't want our resources to be idle for long, but we'll simultaneously want flow to happen. So what can we really do? So finding this balance and making this continued improvement effort for developing the practices how we operate, it's really the key here. Okay, one other example that is usually mentioned when we are speaking about the flow and resources is the traffic. And let's take some of these examples here. So basically, if you have a big number of cars on the road, and you have trying to get from A to B, in that situation, it's going to be very hard. So basically, if you think about that, so if everything goes fine and there are plenty of cars, you probably could get in principle to have a big number of cars driving as fast as one car. But there are some things that really hinder that happening. And yeah, so the more cars you see on the roads, then you are kind of forced to slow down, because you have to take others into consideration and take into account that, okay, what could these people do during while we are trying? We are very big number of cars on that one road. And yeah, if we get two short gaps between cars, so everybody even slow down further. So, and if there's something happening, some disturbances like cars changing lanes, cars enter and leave the road, and then you can easily see that the traffic flow slows down even more. And so there's kind of a full sorry, I got a phone call. Full resource of the road is used, but we come up with the situation that the flow isn't really happening in this traffic jam. And the closer we get to this maximum value of how much the road can take cars, how many cars can really drive on the road, and it seems that, okay, it really blocks us the traffic down, and not everyone is going as fast as they could in other kind of situations. So in order to have flow, you must have some free capacity, whether it's a road, whether it's people doing software development and so forth. So to enable good flow, you shouldn't have fully booked resources. And sometimes you see the number in some cases that, okay, in some types of environment, something like good 80% of resources or the resource utilization is something that you still see some flow happening. But if you go beyond 80%, you see a curve here, which is kind of a hockey stick. It really builds up queues, and the flow isn't really taking place anymore. Whether it's traffic, whether it's our development team and so forth. So if we have too much to do and try to accomplish everything, and we are fully booked already, so we just build up queues and nothing really flows as smoothly as possible. And one thing to understand about flow is that, and if you're talking about good flow in general, there's something called a lead time that is related to that. So how fast can we really get from where we start to our destination? If we start to build a new feature in our product, when we start it, when do we get there and have everything ready to release for the customer, for instance? So lead time is something you measure when you get from A to B, from end to end, and you have everything done. So that's your lead time. And what really affects there is that how many flow units you have in your system at the same time. So if you try to kind of maximize your flow or maximize your resources, let's do that first. So you need to use everyone's time very efficiently and keep them busy all times. Then you just start to experience a queue of flow units, and that is actually needed. So if you just don't want anyone to idle at all, then you need to feed in more work and feed more units into the system so that everybody is busy all the time. Like in a doctor's waiting room, you have a number of people waiting, and if the doctor has something like 15 minutes per patient, and then you have one patient who is actually taking more of a doctor's time, then you start to end up in a queue in this doctor's waiting room, and you don't get to see the doctor when you had your time appointment being settled. And also, if you have a kind of a bottleneck and you start to see that, okay, then the steps that are behind this bottleneck, they get idled as well. So they are waiting for work to come in, but they can't because we have a certain resource that is kind of too occupied with the incoming flow units, and they tend to see idle time too long. That is really slowing down the flow. And like an example, if you have one closed car lane in the road, like in the highway, then you experience that very easily. That you just have to use. If you have two lanes going to the same direction, then the other lane gets blocked for kind of a construction work or something similar. Then you need to slow down, and then when you got past to this block, and then you usually have a free road and you are able to run at full speed again. And also, if you have some kind of knowledge gap or something that you are just not behaving like in a road, like driving a car for instance, and you are doing something unexpected, and people are different drivers. For instance, some are slow, some are fast, some can hesitate to how to drive in certain situations. Then you appear to see variation, and that affects everyone's driving in that road. Or if you have some kind of a skill that is not adequate to do the job, like Charlie Chaplin here in the picture, that he wasn't keeping up with the pace because he was a newcomer in this assembly line, and then disaster disastrous things started to happen. It's a fun movie called Modern Times. So it's over 95 years old movie, but it's still worth to see how the assembly lines and the industrial revolution really affected in the 30s. Okay, if you remember, in the first we spoke about maximizing customer value and try to get rid of wasteful efforts. So what is really waste? So it's kind of wasting our flows, and what really is happening there that when we try to get rid of the waste, we just have to somehow recognize what are these wasteful things that we really get rid of, and which are not really related to customer work. So what's really kind of one way to look at this is the Toyota's way, because Toyota is one of these car manufacturers who are kind of considered as lean pioneers, and they build their culture in a way that really is an example for the whole lean movement, if you will. And there are several books written about how Toyota is working and what is their philosophy, and what are the real things that they are actually doing in their plan to get this the car assembly lines working as they should, and while maintaining the high quality and things like that. So Toyota's view, you get this Tim Wood acronym. I will shortly explain how it's formed here. So one thing that Toyota is looking for, transportation. So if there's something in the assembly line that you just have to move, but you shouldn't, and try to get all the unnecessary movement out from the assembly lines, and all inventory, all which are not being processed, all the work in progress, it's kind of considered as waste, and you should get rid of these inventories as efficiently as possible. Motion is quite close to this transportation, but involving things and persons who are moving, even though it's not necessarily required. If you have to fetch something from too far, then it's kind of you just try to get rid of that extra movement. Also, the waiting we really touched when we spoke about Allison's time, how she was forced to wait for the next step in her examination path. So waiting is of course something very wasteful that we want to get rid of. We produce things which actually demand this just-in-time kind of thinking here. Toyota doesn't produce any cars unless there's some customer demand. So basically, you have to have that before the assembly line even starts. And you do more than actually is needed. So you test more, you add additional steps into the process, even though it's not quite necessary. You just have to deal all this also. And then if you generate defects or problems in the final product, and then you need to spend time finding the fault, what is causing it, and fixing the fault as well. And the thing they added later is this unused skills. So they try to utilize people's skills as widely as possible. So they added also that. So you get this acronym Tim Wood if you just look at the first letters of each of these wasteful kind of considered habits. Okay, if you just compare this, what is then the software view? If we take this Mary Poppendike's book called Lean Software Development, she there mentions also some interesting things for software development organizations, what they should be looking at. And the same kind of Tim Wood acronym here is that if we go this transportation first, then it is kind of related to task switching. So we need to shift our mind or shift our focus during the day too many times. For instance, you have too many times in parallel ongoing, and you need to work on all of those. So that is considered wasteful. And inventory, yeah, it kind of a partially done work. So what is not finished is kind of an inventory, and you need to kind of try to finish things before you start any new things, new development efforts. Motion is kind of a handoff from person to another. For instance, for like someone else is taking a code review for you and things like that. So if you need to do it that often, that's perhaps desirable. But anyway, this kind of a motion too early or too many times could be something that you might consider what is the optimal way of doing that. Waiting is waiting, yeah, like in Toyota's case. So if you have just to wait for someone, for instance, to review your code, for instance, or do the testing for you in certain cases, that's considered kind of a waiting waste. Overproduction in software could be called extra features, that we produce something that hasn't really gotten any customer demand. So we have to be very careful when doing something extra, and if there's no actually pull from customer to do anything like that, and they are not willing actually to pay for it. Yeah, over processing also here. So some extra things, that some unnecessary steps, unnecessary documentation. Can you do a more lightweight documentation, for instance, and things like that? You could imagine that could be taking place in that kind of situation. And also defects here. So defects are not desired in software either. Maybe in cars you want it even less, but not in software. We want to build high quality software with no defects. So coming next to this, what is really efficient way of working? So this diagram tries to illustrate if you are close to this maximum capacity of yours, for instance, as a person or as a team. So what happens usually is that you start to do some secondary needs in case that, okay, when you are fully booked and you start to get some questions. Okay, hey, where is my stuff? Why haven't you been able to deliver this feature and so forth? And that might be that you are fully booked with customer support, for instance, or you have to communicate to stakeholders like your product management or even your customers if there's a problem in somewhere in the field deployed feature or product, and you have to take care of this. And it tends to lead to the situation that this superfluous work, like they call it in this is Lean book, it takes over your time quite dramatically. You have to communicate, and you spend times in the meeting, and if you are kind of try to do some value added new features for customers who are willing to pay, then you are slowing down this green part here. So the primary need is really to produce this value added work as well as possible. But you then if you are getting rid of this resource utilization or heavily utilized resources, then you may be able to accelerate on the value-added work as well. So keeping in mind that you just need to consider that how much can you really take in and how to use your time, and where do you really want to spend your time. So making this in a nutshell, doing many things in parallel is not very efficient. It actually leads to waste, and this red part here, these secondary needs are kind of a waste that you will need to call the customer, for instance, for their problem, or you stop everything that you are doing now, and then you do something else, and you have to restart the original thing that you were actually doing, and that's task switching at its worst, so to say. So yeah, so parallel work tends to lead to task switching, and you increase your lead time as a consequence for that. And trying to prioritize and getting things done one by one is kind of a best way from flow efficiency point of view and lead time point of view to get things done. So there are so many researches on this that you can't really argue that that's truly the case. All right, so if we just check some principles in these two domains, actually the ones that we discussed when we really talked about waste, we had this Toyota view, and then we had this lean software development view. So maybe having these principles from both of these examples in this next two slides. So the Toyota production system is kind of branded as a Toyota way of working, so which they have made very famous in the industry. And what are the kind of basic principles they use? Basically, principle number one is having the long-term view on what we are doing. So having that mindset, okay, we are here for the long run. Toyota has been manufacturing cars for a number of years, as we know, already over 60 or 80 years, maybe even. So even though we have short-term goals, we have to keep this long-term in our target. So having that mindset is not the next quarter, it's not the next year even, it's maybe in 5 years where we want to be. What is our goal there? And actually the meat and potatoes for Toyota is to get the right process. So in order to produce good results, and there are some things mentioned here. I don't think we have to go through everything there, but maybe the most important ones, they are all important, but maybe this create a continuous process flow to bring problems to surface. Like you see a lot of Japanese terms here. If you read lean books and lean writings on lean development, you often come across these Japanese terms on those different practices and principles, and they are made popular by Toyota. So even not always, they are not even kind of translated into English or some other languages. So they are quite heavily also to related to Japanese culture, and you can see them here. Standardized tasks and processes, for instance. Kaizen is the quite famous term in everywhere when we are talking about continuous improvement actions. Okay, heavily put focus on getting the right process in place, Also developing your people by training them and growing the leaders who have the right mindset and actually live the philosophy and teach the philosophy on their employees, and this is highly expected, and respecting people and your partners who are your suppliers, also mentioned here as one kind of a important point, as they really contribute to your flow. So getting them on board and treat them with respect is also important. And yeah, this last pillar is kind of important, and maybe the vital thing, that you just continuously try to resolve the root problems and learn all the time how to run the system in a more efficient way, understanding the problems, making decisions by considering many options that you have in resolving issues, for instance, and become a learning organization. And lean software development, in this lean software development book by Mary Bobendijk, there are kind of similar things like in Toyota's, but a bit in a different angle, eliminating waste, using the value stream mapping for identifying all the wasteful steps that we don't actually need, get rid of those task switching and waiting hands-off defects and so forth. Amplify learning, like in Toyota, you just have to get fast feedback and synchronize and have multiple design options to work with to get the best results and short feedback loops. Deciding as late as possible, and like in Toyota's case, they said that make decisions slowly. So which isn't really the case in some of these current fashionable kind of companies, that we make quick decisions and then try if it works and then decide if it's something that we should do. But in this lean kind of thinking, making decisions when you have everything that you can possibly know from the problem being carefully analyzed, and then do the decisions in Bobendijk calls this last responsible moment. It's kind of handling the uncertainty in the best way that you can. And also deciding late but delivering fast. This is one key thing here. So you need to have all the machinery in place, like your continuous integration, continuous deployment. You shouldn't waste time on that. You have to have it in place, so you can kind of concentrate on the making the customer value, and not this tweaking your CI/CD machinery. Empowering the team, team is able to make decisions and get motivated, and using the pull method of handling their thing, not being pushed by many stakeholders. For instance, that okay, you have to do this. Yeah, I'm asking you to do this. Can you take it? Yes, we can. You shouldn't accept any request, but be in control to kind of keep the flow going in your team. Building integrity in, so kind of integrity is a kind of a hard word for Finnish speakers. And kind of, if you just replace it with quality, for instance, in this case, could be something that we could handle more easily. So test and refactor your code in frequently to get it readable and maintainable, and produce high quality results for customers, and try to meet their expectations, and seeing the whole thing from end to end. It's kind of difficult to in at least in large organizations, but there's a kind of a desire to fill in that request as well, and understand what is the whole thing, that are we truly sub-optimized, or does everyone in the organization know what is the important thing to consider and to focus on. Okay. We are going to Kanban. So what Kanban really is, that it's making work visible. And what is actually Kanban? So how should you understand Kanban? So Kanban is Japanese, as you may have guessed. So it's called a billboard or signboard. So something called visually available and publicly, something you can see in public. Could be an advertisement, for instance, if you speaking in broad terms. But actually, it shows what is happening in your team, and it says here that it's a lean method to manage and improve work across human systems. So manage and improve. So there's a possibility that you can really improve your flows or how you work. If you have Kanban, you can easily monitor what's happening and what things get done easily, how many things get done per week, and so forth. So making this Kanban board really kind of adds value, that you just know in your team what you are doing, but also you can tell others that you are working on this, and this is what is happening right now today. And some examples from having this Kanban board is to have the kind of a sprint backlog of a Scrum team, for instance. That's very common to have it in Kanban as a Kanban board. You may have a product portfolio display that, okay, these are my products, for instance, in the backlog, what is happening with them. So, okay, our organization is working on these 3 products, for instance, or different features, and to see how it's going in this visualization of a Kanban board. And also like a service management kind of a you have requests arriving all the time to your organization, like a customer call center, for instance. You can visualize what is happening to all these call cases, for instance, how they are getting prioritized. Okay, some of them are getting deprioritized, for instance, and which are less important. So you know that, okay, next one that will be in progress will be this one in the highest in this backlog column, for instance. Yeah, so there are many implementations for Kanban. Some key concepts what you can see in the Kanban board typically is having these backlog items. They can be tasks, they can be user stories, for instance, if you are in a Scrum team. They may be, if you're working on a product portfolio backlog, then they are kind of features. So there are different levels of backlog items you can visualize in a Kanban board. And one very important topic is to have this work in progress. So it really says that, okay, how many things we can work in our team, for instance, at the same time. So we now allow that we are, for instance, having 3 backlog items that we are going to work on in parallel in our team, for instance. And there are some stages that we see in these columns also here. So there can be many. There can be quite simple ones, as we see in the later example, for instance. All right, so let's have an example how the team's sprint backlog could look like in the Kanban board. I created a very simple backlog. So you have this backlog for incoming backlog items. Then you have this in progress stage where you are working on it, you are implementing testing and so forth, and then you have the done column at when the things are getting done and delivered, for instance. So let's imagine that we have a team of 5 starting a new sprint, 2 weeks, 2-week sprint, and yeah, they have had the sprint planning session, and they are now committed to the product owner, for instance, that we can work on this 5 user stories or backlog items. And we think after the planning session that we can complete all of these when the sprint is over. After 2 weeks, everything is done. So everything here is now in this done column. So how do we organize our team to make this happen? And yeah, so this team tries to follow the resource optimization model. So okay, we have five people in the team. We have five backlog items. Let's pick all one, and then if we start it at the same time, and yeah, we have agreed that okay, we can work. Maybe this 5 is even too little. It might be indefinite number, like 100 items per at the time. So I just put it here 5. You can see this in this example. So we have agreed, okay, we are 5. We can work on 5 different things at the same time. And yeah, let's do that. So let's try to make it work. So after a week, when we reach the mid of sprint, so we are still working on these items, and it seems that this story number 5 here isn't really started because this guy had to do something else, or he might have a sick leave or something else. But nevertheless, so far so good. These are progressing well, and yeah, and what happens in the end is usually this. So it seems that after 2 weeks we finish something. The red team member is finishing with this S3 backlog item, but others are not finished yet, and we have this S5 also back from sick leave, and he is still in the middle of the work. So it seems that okay, if we work in a manner like this, we have the most important stuff really not done after the sprint. We completed one thing, but that wasn't the highest priority, and we haven't really produced too much customer value after the sprint. So if you calculate how efficient this is, that if you just consider that okay, what truly happens that when you start the sprint, then you might have a chance of 50% of completing all things in the sprint per one person. So you have this 0.5 chance of finishing actually, and when you put it to power of 5, gives you 3% chance to finish everything in your sprint. So so probably the team hasn't really thought about how much true capacity we have for all of our team members. We haven't had really thought about what surprises there may be. We may have sick leaves, maybe we can have some customer support cases that we need to handle at the same time, which we didn't know about and which are urgent to handle right now, or customers is getting very angry. And yeah, so considering the full workday, you just probably can't just allocate your full 8-hour working day to work on these items. You have something else, you have meetings and things like that happening during the working weeks. And if you try to use the team in a flow optimized manner, you probably do something different. And maybe you just allocate the team so that okay, maybe we are not trying to get fully allocated, 100% allocated to each of these stories that we have in the backlog, but we put our focus on the most important ones, like S2, S1, and S2. And we split our team in two and start working with that. So, and we have agreed in our team that, okay, we have the work in progress limit in our sprint. We have put it to three simultaneously parallel items that we work. Okay, and when we reach the middle sprint, we have worked so hard, and we have already actually completed S1 and S2, and we have now started to work on the S3, 4, and 5 using this kind of same composition or the pairing on these items, except this S5 is being taken care of by this one team member. And when we reach the end of the sprint, yeah, maybe we have been able to even finish 4 out of 5 stories. So that's very good. That's actually 4 times more than in the earlier example when the team was fully resource optimized. And if you compare this, that you then have this possibility of finishing your stuff as 85%, for instance, if you work in this kind of setup, then finishing all 5 gives you a probability of 44% or more to finish everything. So that's kind of a big difference if you compare to this resource optimized way of working, when every team member took one story and tried to work on their own. So combining these efforts to use multiple heads, multiple eyes, and make this thorough thinking on things more carefully could be a way to go to get more done. Okay, very quickly about Lean and Agile and Scrum and what is their context. So if you remember this picture from last session I had in September about Agile and Scrum, I showed the same pyramid there as well. So the Agile principles are really heavily based on these lean thinking models. And yeah, if you go through the Agile principles, if you remember, there were 12 of them already. I won't go through, but almost every principle that we see in the Agile manifesto is related, has some kind of origin from lean thinking. I don't go through every Agile principle there, but you can see that there are some lean concepts that are kind of similar or can be related with these Agile principles as well. So I can somehow pause here for a while, and you can check what is in there. Maybe this most important if you just remember this Kaizen principle, which is related to continuous improvement. That is something that you see very often. Often when you are speaking about continuous improvement efforts and so forth. So we are coming back to this or reaching the end of this presentations and a small summary what this presentation was about. So we went through some key lean concepts and principles, and as I just put them here, we spoke about customer value a lot. Putting customer as your VIP is the kind of a basic building block when you are starting your lean journey. Then we spoke about waste, how to eliminate it, what is the method of finding one. You do these value streams and try to identify understand how your product is really implemented and what are the steps really when this product or feature or whatever you are working with is getting produced, understanding that, try to find where to streamline, so to say, your operations. The hard thing is to see the whole picture, whole view from like getting the customer request, understanding what the request really means. You have to deal with the actual requirements, design your work, implement code test, and doing multiple loops and try to automate your work and things like that. See the whole picture, how the value is really getting produced, and finally how to deploy to customer. What is the way to do that? And things like that. So it's quite hard in large organizations when you have sales and marketing and things like that. So get the good view actually of the customer process, for instance. If you have many customers, how you get the whole picture, so you can understand what's really providing the value for the end customer. Continuous improvement, Kaizen. Yes, just mentioned that in the earlier slide. Continuous learning. Remember this principle in Toyota, for instance, get this people trained, developing your people, things like that. You should also book time for learning, because if you are too occupied or too heavily loaded, you just tend to skip that part, which is very vital, at least in the ICT industry, to get to understand better and finding all the time new ways of working and new tools and things like that make life easier. Giving and receiving feedback, continuously respect, develop people, and quite a bit we talk about resource and flow, how to optimize those. We spoke about pull versus push. What is the principle there? How do we pull work? How do we pull in customer demand and try to finish the earlier stuff that we are doing and before getting new work in? It's a kind of a key concept in Lean as well. And this efficiency paradox, you tend to build other less meaningful tasks for yourself if you just are too heavily utilized in resources. So that's what's usually happening, but it's quite hard to recognize always why this is happening. So then you must kind of stop and pause for a while and do the rethinking. So where is your time really going? And Kanban makes the work visible. Work in progress limits, utilize those. You want to start finishing and stop starting work, and that how it makes the life a bit easier. And prioritizing your backlog is also very important. In the left hand column you see the backlog column, and where you see all this prioritization happening all the time. And I would like to leave you with this Bdsa Cycle, that is kind of a one lean tool for learning in improvement. What you can do it. What is kind of a goal you are heading to? What is your objective? How do you plan your next trial or experiment, what you are going to do? And then what will happen if you try something different? What are the risks and so forth? How do we do that? And then you just do it, and then you check the results. Did it really work? And act on the next iteration of the same experiment, or try a new experiment. And yeah, that's the end of my presentations. I guess we will have a Q&A later, because this session was recorded, and I thank you very much.